Hey Garage Fabbers, we're back on the Mighty Max today. We're gonna build some front lower control arms, and I don't wanna waste any time, so let's get in it. We're gonna use the same control arm jig that we used in the last control arm video, but the lower ball joints are significantly bigger than the uppers. So the piece that holds the ball joint is gonna have to be remade, and that's gonna be step one. All right, I got the holes drilled on both sides. One side fits the threads snugly. The other side fits the taper. But what I found out is this 1.5 inch square tubing is too thick to allow the threads to pop through the other side. So if I had some 1x2 rectangle, that'd be fantastic, but I don't. So I'm gonna have to make this work by cutting some of this out and welding it back together. That sucks, but I don't know what else to do. That was far more work than I wanted to do for this one little piece, but the taper now fits tightly in one hole and the threads fit tightly in the other hole. I have enough threads to slap a nut on there to snug it down. Perfect, that's exactly what I wanted. All that's left is to attach it to the sliding sleeve. When I do that, I'm gonna make sure I have enough room for the nut. The nut isn't all that important, but I do want it to just snug it down a little tighter. And I think we're gonna be ready to start on the new control arm. Nope, I lied. Still gotta make that set screw. Then we can move on to the control arm. I am off to a really rough start on these control arms, guys. I'm still not done with the jig. I found some more stuff that's causing me problems. If you haven't seen previous videos where we made the upper control arms on the Mighty Max, or when we made the jig that was intended to be able to duplicate any control arm I came across. So everything is movable and adjustable. The tabs slide, the holder for the ball joint taper slides, so that can be manipulated to fit every control arm, which is important because on the Mighty Max upper control arms, the ball joint was set in between the two bushings. The lower control arm, on the other hand, the ball joint is directly in line with one of the bushings. And I considered that when I was making the jig, but I still managed to overlook some stuff. So here was my thought process. If I had a bushing on either side of the ball joint, it would be positioned like that. But what if I had a bushing that needed to be centered directly over the center sliding sleeve, as we would with the lower control arms? Wasn't a big deal. That was the reason why I pushed the tabs all the way to the end of the sliding sleeve. So all I would have to do is turn them around so that I could position the center bushing. The problem that I didn't see coming was because I had to mount this hole off center from the main tube so that I could put a nut on the bottom. That means that the center bushing also needs to slide over a small amount. And the problem is I need a tab positioned directly on top of this 1.5 inch of unusable space. So I've got two options. I can cut this piece apart so that I can position this hole much further out, so that the center bushing can be positioned on one side of the main tube, or I can create one more special sliding sleeve that allows me to position a tab directly over this center section. And I think that's what I'm gonna do, using a piece of large angle iron. Hopefully then we can move on to creating the control arm. So here's what we've achieved so far using the factory control arm, which isn't much really. We have the position of the ball joint in relation to the axis of the bushings. That's it. This part can't move. We don't have the width of the bushing set yet because the bushings that we're using are going to be a different width than the factory bushing. And we don't have the spacing between the two bushings yet because we don't know how wide the control arm is going to be yet. So all we have is this distance from this pivot point to the ball joint. So now I'm just going to insert the bushing that I plan to use in here, and then using math, perfectly center it with the ball joint. And then we'll go from there. What I'm doing here is basically roughing out a sketch of what I think this control arm is going to look like on some 1/4 inch MDF that I'm going to use for the template later. We are building A-arms, so it's roughly going to look like an A, and I'm sketching it out based on the size and the location of the ball joint and the location of where the bushings are going to be. And then I'm going to fine tune it to make it look exactly the way I want. On the new control arm, I want this front bushing to reach further forward. That will make the control arm a little bit more stable. But more importantly, the reason I want to move it forward is because this oil filter housing hit the old bushing tabs. I had to cut them off to make room. So moving it forward will help, but I can only move it so far forward because of this Z plate right there. So I'm gonna measure from this plate, which is essentially the front edge of the rear bushing, to that plate is 11.5. I'm thinking 10 inches is the max that the bushing can reach forward from the front edge of the rear bushing to the front edge of the front bushing. So again, from the front edge of the rear bushing to the front edge of the front bushing is 10 inches max. I want to mark this to make sure that I cut this so that the metal isn't contacting the bushings anywhere. So I don't know what this is going to look like yet, but something like that. I don't know if we're going to take a little notch out of there or if we're going to do something more gradual. Definitely something straighter. Yeah, I'm thinking we're just going to do this little notch right there. Cut that out, and then we're gonna figure out how big to make this, and then lastly we'll do, ooh, that was really close. So I've decided to copy this, which closer resembles this longer one that I was talking about, and I'm going to make it symmetrical just like this one right here, partially for looks and partially because this section of the control arm closer to the bushing needs to fit between those tabs all the way up to about this point right here. So at about 2.5 inches from the bushing, it could only be 3 inches wide. So at 2.5 inches away from the bushing, which is right here, it can only be 3 inches wide. Half of 3 is 1.5 inches. That's 3 inches right there. So from the bushing to there, and then we'll flare it out, and then we're going to do exactly the same thing on the other side, a mirror image. So that's as far forward as this needs to go. Then it can go more or less straight across. And then meet this bushing right here. So I'm gonna make this a little bit more precise and then cut it out. Well, I changed my mind a little bit on this right here. It looks nice and all with this little curved edge, but this outer edge is going to be 1/4 inch thick plate steel, which means I would have to shape this. And I don't really want to do that. So I'm gonna cheat. Maybe I'm not gonna cheat. I was just going to lop this little edge off, but the air spring actually needs to mount right around in here. From here to here is the radius of the bag plate. So the bag plate is going to be double that. Basically mounted right around in this area somewhere. So you know what? I changed my mind yet again. That little curve is gonna stay there, and I'm just gonna have to shape that 1/4 inch thick piece of plate to fit that. It's probably not that big a deal with a big old hammer. So this is pretty much ready to go. I'm gonna cut this out in a plate 4 times. The top pieces are going to be cut a little bit different, but to start out, I'm just gonna make 4 pieces that are exactly like this. We will handle these holes a little bit later on. Right now, we're just gonna cut this overall shape out with the plasma cutter right now. All the long edges of these are perfectly straight from the edge of the steel that I used, so I'm going to use these edges as the main edge that I'm going to line up everything else with. So I'll use those edges as the main edge, and then the next longest edges are this edge right here. So those will be the next ones that I line up as close as possible, and everything else I'm just going to have to smooth them out later. Like these are like all over the place. Right now I'm just clamping them together. Some clamping pliers. Now these are perfectly straight. I don't have to focus on that a whole lot. I gotta smooth out these curved edges, and I'm gonna smooth out these, and then we'll go from there. I'm gonna jump ahead real quick, even though all the edges aren't evened out yet. I still gotta do these back edges and I have to do these bushing edges. But I want the ball joint to be in the exact same spot on the left side and the right side. Because assuming that the upper ball joints are in the exact same spot, if the lower ball joints were to move in or out, it would be uneven camber left to right, or if I didn't position them the same this direction, it would affect caster, which we'll talk about that stuff when it comes time to aligning this truck. That'll be a good time. So because I want to do left and right sides exactly the same, I'm going to take 2 of these and I'm going to create the holes where the ball joints go at the exact same time. I decided rather than trying to clamp these together and move them around to the drill press and all that stuff, I'm just going to tack weld these together. I have a 1/16 inch gap all the way around when I put this ball joint in my control arm. I think that's acceptable. What do you think? The factory control arm and the factory ball joint fitment is a hell of a lot tighter than what I was gonna give, but I'm not excessively worried. The only thing I can think of is if my wife were to slam into a curb at some point, it might shear off these 3 bolts, and the tight fitment in here is what would keep that from happening. But just a 1/16 inch wiggle should be all right, right? I don't have, I think it was a 48 millimeter hole saw that I would need in order to do this. The closest thing to 48 millimeters is 1 7/8 inches. Does Home Depot have like 1 7/8 inch hole saws? I know I don't have one. I only have like a 2 inch, which is what this is. If I can get one from the store, I would rather do that. But if I can't, I'm just gonna have just a little bit of wiggle in there. Yell at me if you want. I looked up 1 7/8 hole saws online and Home Depot popped up, so I'm on my way. Hopefully it's not one of those things that you can order online, but they don't actually carry it in the store. That frustrates the crap out of me. Here's to hoping. 1 3/4. That's like, oh, 2. Great. Let's try Lowe's. Well, this project's being a little more frustrating than most projects. Neither store, Lowe's or Home Depot, had an 1 7/8 hole saw, even though they're available online. So I've got to come up with something else. And while driving, I was thinking maybe I plasma cut the hole and I just need to make the hole in the template larger to account for the offset cutting portion of the plasma cutter. If you've been watching the channel for a while, you've seen me trim down wooden templates because the plasma cutter doesn't cut straight to the edge of the wooden template. So you actually have to shrink the wooden template down a little bit to get the correct size part. But I didn't do that on these control arms because I didn't really care that they were just a little bit bigger. It's not that important. This hole, on the other hand, if I use the plasma cutter inside the hole in the wooden template, the hole will be too small. But if I make the hole bigger, then maybe that's an option. But then I have to figure out how big the hole needs to be to account for the plasma cutter not cutting right up to the template. You follow? My quick head math while driving, which means it's not going to be correct, since the plasma cutter cuts about 3/16 of an inch away from the template, if I make the hole 2 1/8 inch, then that 3/16 around will equate to 1 7/8 inches. So that's what I'm going to do. First, I got to make the hole in the template bigger and then plasma cut out the hole. And I expect to have to smooth out the hole. I could do that with the carbide bit in the router trick. If you haven't seen that, that's fun. But first I have to make the hole in the template bigger. And this is one of the good things about YouTube, is though I like to try to teach people the things that I know, people in the comments teach me stuff that they know, and I actually learn some stuff from you guys. One of the things I learned from your comments was in a video that I made with this, which is a hole saw guide for making holes larger when you no longer have the hole for the pilot bit. Someone said that you can use the original hole saw inside the hole saw that you need. And unfortunately, in this instance, it does not fit in the hole saw because of a weld bead, but it does fit backwards. And I feel like this is all I'm going to need in order to center this larger hole saw in this existing hole. That's nice. That is nice. Yeah, buddy. So I am going to use this hole in a piece of scrap metal so that I don't ruin these control arms, to see if this hole with the plasma cutter will make the proper sized hole in the scrap metal for the ball joint, or at least very close so that I can smooth it out with a carbide bit. Well, that was awesome. Drum roll, please. I said drum roll, please. Well, the hole is certainly not too big, but it's close. So I think I'm gonna do that. I'm gonna do that in the actual control arms and then smooth it out. But first, rather than clamping the template like we've been doing, let's drill out these holes so that we can bolt this guy to the control arms. I don't want to fumble with a giant piece of flat stock, so I'm just going to take a rough measurement of this, and it's going to be 34 inches. Cut out a 34-inch piece flat stock and start forming it right in there. I just gotta bend up these tail pieces, but I don't really want to touch it right now, even though I'm guessing this strap might be a little bit softer right now and easier to bend. So maybe I'll try to put it into the vise with some pliers. Yeah. And try to just finish this up for the night. Why not? This is nice and cool now. It's looking pretty good. I'm happy with that. The ball joint bolts in there. This part is going to be welded right on top. But before I do that, I want to do two things. I'm going to cut this plate back because I need to be able to get this in and out. And also I will be adding some more of this 1/4 inch flat stock on the inside there. It's that time again where I need to chill out for a minute, slow down, and make sure I'm not screwing things up. I need to make a left and a right control arm, and knowing me, all I gotta do is weld stuff onto the wrong side of that, and then I have two of the same control arms. So I'm gonna make sure I have a mirror image, and since I have the braces made already, I'm going to just weld these on so that I don't accidentally put the outer perimeter on the wrong side. I am kicking my own ass left and right on this project. I screwed myself over twice with one stone by welding these on first, which is not what I did over there. By welding those on first, it caused this plate to warp. That's awesome. And also, remember when I used 2 plates in order to help me form this outer edge? Well, I can't do that anymore because these are in the way, and I just didn't think of that. So forming this outer bar is going to be a treat, and I have to figure out how to correct this warpage on this plate here. After racking my brain for like 4 seconds straight, I realized I have 2 more pieces, which are essentially just caps for the control arms. I am going to put these 2 caps together, just as I did when I was forming this outer edge, and I will form the outer edge on the cap portion instead. I just have to make sure that I don't weld it to the wrong side. Perhaps you noticed I didn't weld this part of the top plate, and that is because I need to be able to access this section in order to get the ball joint in and out. So I will actually be cutting this part of the top plate off. I'm going to drill some holes in the top of this that line up with these inner supports so that I can put a few plug welds right on top of them. I'm just gonna eyeball where these supports are. I can see the end right there and right there. And then they continue down until they bend over here. So then they're straight from those 2 points. Connect both ends. And connect both ends. And hopefully when I drill through these, it's going to line up perfectly. I don't know if you noticed, but I didn't measure the spacing of these holes or anything because I don't care. They're just plug welds. These will get filled up, ground down, and they will hopefully disappear. I just got some stuff in the mail that I'm gonna try out. I got this flexible hose that I have currently sitting on top of a fan that I keep myself cool in the summer. And I got this vent fan that's gonna mount in the wall. We'll see if it pulls fumes out of the garage the way I hope it does. This is amazing. Did I film this already? I made these edge pieces too long intentionally so that I wouldn't make them too short, which ironically is exactly what happened over here. But these, I've got to trim off. Well, the main structure of these control arms is done, so it's time to bring this beauty back. The control arm jig is already set up for this control arm. We're going to put in the ball joint. Is there any reason why I shouldn't be using the new ball joint? I don't think so. There will be no welding on this side. I'm doing this backwards though. I would probably cry. Now it's time to use these tabs. We didn't want these before because the original control arms did not seem to be made super accurate. We want to put the bushings in there. And I don't know what I did with the bolt. Now I want these Zerk fittings to be on the bottom of the control arm, and we're looking at the bottom right now. Now I get to place this bushing wherever I want right now because I haven't built the tabs for this bushing yet. I'm going to use this control arm to help me locate where those tabs are going to be. So I could just eyeball this and put it wherever the hell I want. So I'm going to tighten this one up so that I can make sure that this Zerk fitting doesn't move, and I need to loosen this one so that I can turn it so that the Zerk fitting is up on top. So I don't know if this shrunk when I was welding or what, but none of these are meeting the bushings. There's a decent sized gap on all of these. I'm gonna say that I made a mistake somewhere. So I don't have to notch these sides or anything. I just have to fill up this gap. There will be some more pieces that go on top. So if all that being just weld bead is a bad thing, I got something that'll make it okay. You can tell me what you think later. Bushings are set in place. I'm gonna wait for this to cool, let any contracting that needs to happen, and then I'll take it out of the jig and weld up the other sides. And then hopefully any change that happens is nothing that the alignment cams can't handle. Currently I can't weld in here with this aluminum there. I might have to shape the edges of these a little bit. so that the bushings aren't damaged by the weld bead in here, but I don't know. After we take it out of the jig, we'll figure it out. So hopefully this isn't one of those times where you get to watch me screw up and then be mad at myself because some laziness is taking over. I've developed the flu over the last 24 hours, it seems, since I completely finished this control arm, as a matter of fact. All I have left to do is to put the bushings on the control arm for the opposite side, but I can't get to the other factory control arm. I could see it. It's on the other side of the shop. I just don't have it in me to dig it out. So I'm not gonna. But here's my thought process. This piece for the ball joint is already set at the distance away from the bushing that I need. I already know that. I just need to not loosen this bolt and everything should be fine, right? So with this jig, I need to move this over, and then I will measure and position this ball joint exactly in front of these two tabs, which is exactly what I did before. So it shouldn't matter, right? All that matters is the length of the control arm. That's set. It's done. I can't mess that up. I basically just need to slide the ball joint over to the other side to make it a mirror image, take these tabs off, move them to the opposite side, and we're good to go. So here's the hooping. All right, control arm jig has been reversed. Ball joint is in the exact same position away from the bushing. Ball joint is centered right on this first bushing. Second bushing kind of doesn't matter. The control arm is going to tell me where to put it. I'm going to weld it on, and then the control arm will really tell me where to put the bushing tabs, but I think we went over that already. On this control arm, I'm actually having to notch out the ends of these in order to get this side to swing closer, to get this one centered. See how it's not quite center? Because I can't get this one close enough. That's much better to me than not having enough material. Basically like this over here. That sucks. But that's all right. We'll figure it out. Because these control arms appear to be so much closer to these bushings, it's not even so much closer actually, it's only like a 1/16 of an inch, but these were pressed directly up against the bushing and I wouldn't have been able to get weld all the way through the thickness of this metal. So I put some bevels on there on all four sides, which gives me a nice open face to lay a whole bunch of weld down right there, right where it meets the bushing shell. Look what I just did. See anything missing? Huh? Compared to this one? Look at that. I almost forgot to, well, I did forget to reposition the Zerk fitting hole right on top. I already put a tack weld. Could have been much worse. Much worse. So I was just thinking to myself, what would I have done if I didn't notice that the Zerk fitting wasn't in the proper spot and I welded it on completely? Would I have cut the entire bushing sleeve off? No, I wouldn't have. So I think I might have been making a bigger deal out of it than it actually was. All I would do was weld that port shut wherever it was and then drill and tap a new Zerk fitting hole in a different spot. I don't think that would have been that big a deal. I've got one more thing to do to these control arms before I call them finished, and I want to bring up something from a previous video. In the past, I have allowed the YouTube algorithm to rush projects. You see, YouTube rewards creators that put videos out on a consistent basis, be it daily, weekly, monthly, whatever the schedule is. And I have allowed that knowledge to rush projects and even say that projects are finished when I knew they weren't. The one I'm referring to right now is the upper control arms. YouTube viewers made me realize that, one, you guys are super smart, and that I'm not going to be able to get stuff by you, and I can't let the algorithm rush me that way. What am I talking about? On the upper control arms, I stole the outer bushing sleeves from the factory control arms. The problem is the factory control arms completely encapsulated these bushing sleeves. These bushing sleeves are incredibly thin, practically sheet metal. They are not thick enough to stand alone. Now, I had always planned on making something to help strengthen them and help them attach to the control arm itself. Basically, something like this. But this was going to take me a really long time to make, and the video would have been late. So I said the control arms were done. For that, I apologize. Justin from the Fabrication series came through and cut out a bunch of these for me. Not only for the upper control arms, but also for the lower control arms that I'm doing today. 2 different sizes. What is it? 2, 4, 6, 8, 16 of these. 16 of these would have taken so much time to do by hand. It's doable, but it would have taken hours. And to be honest, I was just feeling a little bit too lazy. Justin cut these out on his plasma cutter, and they look fantastic, and they're really going to make these control arms and lowers really shine. So I'm going to put these on the lower control arms and the uppers that I should have done a long time ago. Oh man, things were going great. It's about time to change out the lens on my welding hood. Now, I just want to point out before somebody else does in the comments, because they absolutely will, these control arms are stupid heavy. Terrible, terrible design for performance, but they're gonna make it sound like it's deadly. I don't know what they think is gonna happen, but I am going to do a suspension basics video in the future talking about suspension component weight, otherwise known as unsprung weight, why it's important, why it's better to have much lighter suspension components, and how it affects handling. But that's going to be a long video on its own, so we're not gonna put it here, but it is coming, I promise. I think that's gonna be it for this one, guys. I can't say that the control arms are done because they're not. Before we send them out to powder coat, we're gonna need to attach some bag mounts to them. There's also going to be some shocks somewhere around in the front area of the control arms that attach them to the chassis. But structurally, I think we could say that they're done. We're gonna be picking up speed quite a bit on the Mighty Max. Thank goodness the heat is gone. It went from like 107 to the garage to like 40 overnight. Super happy with that. Some of the other things that are gonna happen are the front tabs for the bushing up on the front side of the control arm. And getting the air springs all set up with upper brackets on this. This entire area here is probably going to get completely rebuilt. Don't really know what we're gonna do just yet, but it's coming. I'm looking forward to it. And until the next one, my friends, keep moving forward.